our topic will be personal safety measure. So, as we know the saying that a prevention is better than the cure. So that's why following the safety precaution must be taken while working with the electrical installations or while handling with the electrical appliances. So that's why a prevention is better than the cure. So that's why now we are discussing with the personal safety measures. So first, before knowing that, let us know what you mean by electric shock. So whenever we are using with the electrical equipments, sometimes we will feel shock. So many cases, almost everyone would have felt the shock, right? So whenever a person comes in contact with the live wire of the electrical supply, he gets an electric shock. It may be a mild or severe, it depends, whatever the amount of current flows through that. So if the mild shock will produce a nervousness and severe shock will produce the unconsciousness or the death. So a sudden agitation of a nervous system of a body due to the passage of electric current within the body is called as a electric shock. Then what are the different factors which will be affecting the electric shock? So the different factors which will be affecting the shock is nothing but the magnitude of the current flowing through the body. So whatever the amount of current which will flow through our body. Next, the path of the current through the body and the time for which the current passes through the body. For how many duration the current will pass through our body. Then the frequency of the current and the physical and the psychological conditions of the particular person. So these are all the major factors which will be affecting the shock. Before discussing the safety precaution, so let us know what we have to do when a person gets electric shock. The main thing, do not panic. We should not panic during that particular time. That's why while discussing the previous topic, we told that a physical and the psychological conditions of the person who gets a shock. So we should not panic. Next point, do not touch the victim with the bare hands. If any person felt shock, so other person should not come and touch him directly or with any metallic part or with any contact with the electricity. Next point we should do is we should switch off the supply immediately. Then once the victim is free, check his breathing and pulse. We must check this person's breathing, whether is breathing and the pulse rate of him, the heartbeat. So all those things we should do. If the breathing stops dangerously, we should do a artificial breathing for him. And we should not give anything to the victim to drink when he is unconscious. So these are all the things we should do when a person gets a shock. Then what are the safety precautions which can be taken to avoid the electric shock? So one thing is make sure that all the metallic parts of the electrical equipments are effectively earthed. So all the equipments what we are using, electrical equipment, it should be earthed. That is the main thing to avoid the shock. Second point, broken switches, plugs, etc. should be replaced immediately. If you have any broken switches or the plugs or any wires, right, it should be replaced immediately. And before replacing a broken switch, a plug or a blown fuse, we should switch off the main supply. By keeping the supply on, we should not do all these things. We should switch off the supply, then only we can replace all these things. And never use the equipments and the appliances with the damaged or the frayed lead wires. So if the skin of the wire is taken out, right, all those things, wires should not be used. And never insert the bare wires in the holes of a socket for taking a connection. Always use a proper plug. So we should use a proper plugs for any equipments, and you should not use the bare wires which should be inserted directly to the socket. And always we should use the well insulated tools. And current rating of the fusing wire. So we already discussed in the previous classes, the fuse wire should have a current rating so that it will avoid the shock. And never try to connect a machine or the equipment to a voltage supply other than the rated one. So whenever you have some equipments, it will have rated current and the rated voltage, right? We should not connect that particular machine or the equipment other than the rated voltage. If the component what you are using is a 230 volt is the rated voltage, you should not give more than that. You should not give a 3-phase supply of 415 volts for a 230 volt machine. While working on an electric pole or a tower, use safety belt and the rubber padded ladder. So while working on the poles or the towers, any repair works is doing, right, we should use a safety belt and the rubber padded ladder. We should not use any metal ladder, because a metal is a good conductor. If you are standing on that, I find if you are doing any repair work, obviously we can experience the shock. That's why you should be used with the padded ladder, and they should use the protective gloves. Strictly follow all the precautions and the instruction given in the nameplate of the machine when you are working, and be careful that your body does not touch the wall or any metallic frame when you have in contact with the earth while you are working with the electrical equipments. These are all the safety precautions we must take to avoid the shock. Then what do you mean by earthing? So in the first point itself, we told that what all the electrical equipments or the machines we are using, it should be earthed. The connection of electrical machinery to the general mass of the earth with a conducting material of a very low resistance is called earthing. So it's nothing but it is the process of transferring a immediate discharge of whatever the electrical energy is directly to the earth with the help of a low resistance. So the earth resistance is approximately equal to 0, or it will have a very low resistance. Then what are the objectives of earthing? So before that, what is the necessity of earthing? So to protect the operating personnel from the danger of shock in case they come in contact with the charge frame due to the defective insulation. So whenever the person comes and touches any particular electrical equipments, right, it have as a defective insulation, obviously you can feel the shock, right? If I have done the earthing, which will have the low resistance, as we know the concept that the current will flow through the least resistance path. So that's why if you do the earthing, which will have a low resistance, it will be approximately equal to 0. Obviously whenever short circuit occurs or any fault occurs, when you come and touch that particular part, if earthing is not done, the current will pass through the person who will be touching that. The human body resistance will be very less, which will be approximately around 500 to 1000 ohms. That's why the current will flow through us and we will feel the shock. If the earthing has been done, the earth resistance will be around 5 to 10 ohms. Obviously the maximum current will flow through the earthing point, and only the few amount of current will flow through us, so we will not experience a shock, or if we experience a shock also, it will be a very mild one, so it will not damage the person. And to maintain the line voltage constant under the unbalanced condition, whenever you have unbalanced condition, if I have done the earthing properly, the excess of current or the leakage current will flow through the earthing, so that we can maintain the line voltage properly. And for the protection of the equipments and the protection of large buildings and all the machines fed from the overhead lines against the lighting. So whenever the lighting occurs, the heavy amount of current flows through. If earthing is done, that leakage current or the heavy amount of current will flow through the earthing, so it will avoid the equipments to get damaged. Now what are the different types of earthing we have? The main types of earthing what we have is a plate earthing and the pipe earthing. The earth resistance of a copper wire is 1 ohm and the GI piper is less than the 3 ohm. The earth resistance should be kept as low as possible so that neutral of any electrical system, which should be earth, is maintained almost at the earth potential. So whatever the earth resistance at the powerhouses, it will be around 0.5 ohm, and at the substation it should be 1 ohm, because at the powerhouse we will be generating the power at a very large rating, and the current flowing at that will be very high. So that's why we should maintain the earth resistance at only 0.5 ohms, and near the substation also at 0.1 ohm.